Okay, so now we've talked about and or and what they mean qualitatively, but let's take a look more in depth in what they actually mean when it comes to Venn diagrams and set notation. When you have an intersection, so the and portion, if I was to draw a Venn diagram, this middle part here where they overlap, we can denote that with a little symbol. This one right here. Looks kind of like a lowercase n, but it means this set A and set B. For example, the number 2 would be a value that belongs in both the sets of numbers but less than 1 and 5 and even numbers. So that would be an example of and. Whereas or is the same thing but with an upside down. Looks like a U. So A or B would look like this. Again, it can be both set A and set B. Let's take a look at an example. So we have the universal set where x is less than 10 and part of the natural number system. So that's 1 to 10 basically. In that set, we've taken out two subsets. Subset A, which is the numbers 1 through 6, and then the set B, which is the numbers 5 through 8. We're now going to list the elements in the sets. So in set A and B, we have we only have the ones that are actually in both. So that would be 5 and 6. 5 and 6 both exist in set A, and they both exist in set B. In set or B, we have the entire set of A, and we have the entire set of B. But make sure you don't rewrite the two numbers you've already written, the 5 and the 6. So A or B includes all of the numbers in A and all of the numbers in B. A prime and B. So remember, this means not A. So if I drew a Venn diagram, and this is A, this is B, well, it's everything outside of A and everything that is in B, but not the portion that overlaps with A. So that would include 7 and 8 only, because it's none of these, but it is B as well, so it has to be 7 and 8, because it has to also include B. A and B prime, so again that's A and not B. So A has to be included. So if I drew my Venn diagram again, we have everything not B, so that's all this stuff. But we also have the fact that A has to be included, so it has to also include this. Just like this last one also had to include B, that's why it was just 7 and 8. In this case, it's just going to be 1 through 4. And then not A or B, well, that would be, can't be A. So that would include this portion, because that's the not A portion, or B. So in this case, remember how B is this right here. Well, it's either not A or it's B. And so this is the or it's B portion, and this is the not A portion. So we include that overlap part there. So we'd have 5, 6, 7, 8. And we'd also have 9 and 10. because it's including these numbers out here. So let's go through a little true and false thing. 2 is an element of A. Well, A is up here. Is 2 part of it? Absolutely it is. 2 is a subset of A. Well, 2 itself is an element, not a subset, so that is false. A is a subset of U. Yes, that is true. A is taken away or taken apart from the universal subset. The universal subset includes all of the elements, and so from all those elements we picked out our subset. 2 is a subset of A, but this, since it has the squiggly brackets, it's saying that that set, whatever that set is, this set has just got 2 in it. So 2 is a subset of A, and yes, we've taken out, if you were to make a subset of just numbers that are equal to, well, that would be a subset of, that is a subset of A. So that would be true. And then 0 is a subset of B. So again, this is just an empty set. And you can make an empty set out of B. So that would be true as well. The last one, the number in the set A and or B equals the number of A plus the number of B. Well, let's find out. When we look at A or B, that's here, the number was 4. So does this equal 4? Let's take a look. Number of A is 1, 2, 3, 4, 5, 6. The number in B is 4. 6 plus 4 does not equal 10. Or sorry, does not equal 4. So that is false. Moving on to visually see these relationships. The intersection where set A and set B would be here. If we have a union, it's called, the and is called the intersection, and then the complement where it's the not part is the A prime there. So union, A union B, is all of A or all of B. So that would include all of them. I can make it look a little bit nicer. Not A would be everything except for anything that has the A value. That would not include the overlap, but it would include outside of the circles, like so. Now we have a couple different sets, set T and set F. Set T is multiple of 3's, set F is multiples of 5. Of course, the universal set includes both of those and has been defined as n is less than 20. We're going to shade the different regions that are described, and then we're going to describe the set using either words or letters or whatever. So the first one's done. This is set T, and it includes everything in the circle of T. The next one, set F, well, similar to set T. Everything in the circle of F. The number in the circle of F is 4. There are 4 elements in that circle. We would consider this just set F, nice and simple. Set T prime. Well, that's the complement, if you remember, of T. So that's everything except for T. And we'd call that not T. The number of not T, there is 1, 2, 3, 14. 14 items that are not in the subset T. The items that are not in the subset F, just like T, we're going to exclude F. And this is called not F. And the number of items that are not in the F category is 16. Set T and F. Recall that U is the intersection and it means and. That would be where they intersect. Their subsets would be T and F, and the number of T and F's is just 1. There's only one, number 15. Set T or F. Recall that that means union. So in the T or F's, there is all of T and all of F. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9. No. Looks like 10. Oh, no, 9. Set T and not F. So this cannot be F. We do not have F. And we do have T. So we're going to obviously not include F. But we also can't include this overlap portion because it cannot be F. It's not F and it is some T. So it can include T, but just not that overlap. And we just call that not F. Oh. What am I doing? I've messed up. So it's T and not F. We can't have this, because this would be considered not F, but it wouldn't also be considered T. We need it to be in both the subset T and the not F part. So we can't include this part. We can only include this portion. And that would be considered T and not F. Or we could say T only, because this 15 here is T and F. So it would just be T only. And the number there is 5. In this portion, T union not F. So it's either T or it is everything that's not F. So in this case, we would include all this stuff. Now, do you think we're going to include the middle part? Let's take a think. T or not F. So yes, it can be T. So that middle part would be included, because it's either T, which includes everything in T, or it's not F. That would just be T or not F. And the number in there is 17. Not T and not F. Well, that would be everything that's not T, so we can't include T. But then we're also not including F. So we're not going to include any of the circular parts. Just be like that. I mean, not T and not F. And the number there would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If we look at this one, set not T or not F. So this one's a little bit more difficult. Let's just do the not T portion first. Oh, this would be included for the not T. So that's not T. I'm going to change colors and make not F. Not F would look like this. Oh, I can't touch F. So what we're actually left with is that the entire thing, except that middle portion here, is filled in. So we would call that not T or not F, and we would only have one item. Or sorry, no, we only have one item left, which means we have 19 items that are either not T or not F. In set T and F not, we have something interesting as well. So let's start with set T and F. Oh, this part here. That would be set T and set F. But we want everything except for that because of this thing right here. So we're going to end up with the exact same thing we had over here because it's everything but the intersect point. So I'm just going to actually take this whole thing and duplicate. And we're left with not T and F. And again, we have 19 things that are not T and F. Set T or F not. Well, let's first do T or F. And then it's not that, it's everything else. Which means we get rid of all this and we just include the outsides. This is probably something many of you have never really dealt with before. And it's really weird terminology. But the more you practice it, the better you get. This would be considered not T or F. And the number in the not T or F, there are 11 items outside the circles. Let's do another example. This is very similar to the example we did yesterday, but we'll give it another shot. So we have this Venn diagram that represents a certain amount of graduating students again. Of these students, 15 of them play volleyball, so that's this whole circle has to add up to 15. And 20 of them play basketball, so this whole circle has to add up to 20. There are some overlaps, so it's not just 15 and 20. And then there are 33 students who don't play either sport, so those are outside. They're still graduating students, but they're outside. And we can say that right now, number of students who don't play. Do we have that question? Number of students who play volleyball and basketball, number of students who played volleyball or basketball, number of students who did not play basketball. No, we don't have that one yet. So we can't answer any of those yet. But we can find out how many students are going to be playing basketball and volleyball. First, let's take a look as if all of the students, all 15 who played volleyball, only played volleyball. And all 20 that play basketball only played basketball. That would be 20 plus 15, which is 35 players if they had only played basketball or volleyball. If there's 60 graduating students and 33 of them don't play any sport, then we're left with 27 athletes. And if there would have been 35 for the individual sports, but there's only 27 allowed, well, obviously we have an overlap. So that overlap is just the difference between the two. So there are 8 students who play both sports, because that's the only way the numbers will actually work out. Once we've got our 8 students, we know that there's 20 in this whole Venn diagram, or in this whole circle, that whole set. So we just take 20, subtract 8, we're left with 12 that only play volleyball. Similarly, that 12 should be for the basketball because it's 20. The volleyball is 15 minus 8. We get 7 that only play volleyball. So the number of students who only play volleyball, 7. Number of students who play volleyball and basketball would be would be the middle part, 8. Number of students who play volleyball or basketball, well, that will include this whole region. And we get 8 and 12 is 20, 27. Number of students who do not play basketball, well, that would be this group and this group, so 40. The number of students who play only one of these sports, so that would be this guy and this guy, 19, because they only play volleyball or they only play that basketball. The last couple pieces of terminology we're going to talk about is the disjoint sets. So these are sets that don't overlap. So this could be like numbers that are divisible by 3 and numbers that are divisible by 2. And then the universal set is numbers that are between 1 and 10. So we would have 1, 2, 3, 4. And then if we included 10 to be there. So they both don't have anything in common as defined by their sets. They do not overlap at all. The number of A's or B's would just be the number of A's plus the number of B's, the number of elements in the sets of B and number of sets of elements in A, if the sets don't overlap. Recall my 1 to 10 numbers. We would have 5 over here and 5 over here. The total universal set would be the entire A or B. What will always be 0? Well, the number of elements that are A and B. If those are not touching, there are no elements that share both traits. For the sets that do overlap, this portion here, the value for A or B is not the same as it is for this one. The value for A or B is the number in the set A, which would include all of this, plus the number in set B, which includes all of this, and then you'll see that there's that overlap. So we need to subtract that overlap from the total number. And that number is going to be the number of A and B's. Okay, so that is all for today. Tomorrow we will do the applications of set theory, and that'll be it for the unit. Have a great day.